Hi everyone, today I will introduce workshop of Introduction to Data Visualization with R. First, let's jump into the outline. Uh, First, we introduced how to use the Google Colab environment in order to create an account and use the interactive notebook in order to create the visualization by using the R programming language. Then we'll go on the instruction of how to download dataset for visualization in this workshop. Then we will introduce the data preparation by using our programming language, for example, importing the data and cleaning them. And then we'll introduce the famous ggplot2 library that could be used for lots of compelling visualization, introducing first working example of using ggplot2 within our programming language framework, bar charts, pie charts, choropleth maps, time-dependent graphs, statistical models, 3D scatterplot matrix, and at the end we will introduce how to save the graphs and show the plots to your users. As I said, the prerequisite for the workshop is to have a Google account that could be used to just use the Google Colab notebooks. And I'm the Mehrdad Yousefi Data Visualization Engineer in Clemson Data Visualization Lab. And my office hours are Monday 10 to 1, Tuesday 10 to 3, and Wednesday to Friday 10 to 2. So if you have any question, feel free to shoot me an email here at yousefi@clemson.edu. A side note is that this workshop is just we go through the materials, but we don't run the actual code to show the visualization, but you have access to all the visualizations saved in the public notebooks that are shared in these workshop materials. So please go to our website, sitesgoogle.com, g.clemson.edu, VizLab Introduction to Data Visualization with R, and you can find lots of information about other data visualization workshops. And if you have any question, feel free to ask, or if you have any request for a specialized workshop, please shoot me an email and we could discuss that together. So let's jump on the first section. Prerequisites for data visualization with R. R is a powerful high-level programming language that is used extensively for rapid prototyping and specifically for data visualization and analysis, as well as machine learning. Furthermore, R bindings are the best tools available for all kinds of data analytics and visualization in engineering, computer science, and human-related subject studies. In data analytics and visualization with R, the basic concept is to maintain and organize the raw data in arrays and numeric tables, and then use available special visualization bindings to create plots and charts in order to convey an important message to find a hidden relation in your data set. One of the main advantages of using R is its extensive ability for creating a compelling and reproducible visualization that could be shared easily among researchers and collaborators by using a virtual notebook called Jupyter Notebook. However, installing R and all of the required dependencies might be a little bit difficult for new users. As a result, recently Google launched its virtual notebook that has all the famous and interesting R bindings, which is called Google Colab. In this section, we'll learn how to initialize the R environment by using Google Colab. Creating account and login into Google Colab environment. In order to use R environment available in Google Colab framework, you need to use your Clemson University Google account, g.clemson.edu, or any other personal Google account that you want to use might be fine for creating the R environment in Google Colab framework. In order to log in into your account and create a blank R notebook, follow these steps. 1. Go to Google Colab website, colab.research.google.com. Use sign in to enter the Google Colab account. Use your g.clemson.edu Google account. After successful login, create a new notebook, which is shown here. If a new notebook is created successfully, you should see this blank notebook similar to this screenshot. So here you should see the blank notebook. Now downloading the data, download the South Carolina COVID-19 dataset at the county level for April 20, 2020 from New York Times source. Download the US COVID-19 dataset at the county level for June 24, 2020, again from the New York Times. Breast cancer data from the University of Wisconsin, which is shared here. And these are the all free datasets that you need to use for the visualization. How to initialize a blank R notebook. In order to open a notebook with R in Google Colab environment, use this link. Loading R libraries. In this section, in order to import datasets into R framework and be able to manipulate and extract information from them, we need to load 3 different libraries as readR, read CSV files into R data frames, stringR help to manipulate column names in loaded data frame, deployR help to manipulate dataset and summarize the information. So these are the 3 different libraries that we need to import for working with data and cleaning them. Importing data into R notebook. In order to load a file into R notebook, click on Files and then upload to Session Storage, and finally choose your file, which is the breast cancer data.csv in this section. Loading data into R notebook by using read CSV. In order to read CSV comma separated value files into R data frames, we use read CSV function from readR library. So you can see the syntax and how we use that to read that breast cancer data from the University of Wisconsin. Connecting column names to avoid spaces in R. Correcting column names to avoid spaces in R. Our language does not tolerate spaces in the name of the columns associated with data frames. As a result, the spaces should be replaced by dots in order to avoid unnecessary errors. The stringR library helps to identify spaces and replace them with dots. So we just take the column names of breast cancer data frame, and then we replace all the spaces with dots, as is shown here. And then we could just print them again, and you see that every white space is replaced with dots, which is acceptable in the R language. Select filter and mutate the dataset. Select function from dplyr package is helpful when you want to select specific columns based on their names. Filter function is useful when you want to filter the dataset based on a certain condition or multiple conditions based on values of columns. Mutate function will be used for creating new variables based on combination of existing columns. Summarizing dataset based on aggregating columns. In order to aggregate and summarize dataset based on, for example, taking mean of columns, we use summarize function. Note that na.r should be equal to true, removes missing values in columns during averaging or taking maximum or minimum. So that could show you the mean, value of radius, and texture parameters. The R notebook to reproduce these results is shared here. So you can jump here and see all of the created results by yourself and run them again to just get the same results and make sure that you have the reproducibility. Introduction to ggplot2. In order to reproduce the visualization given in this section, you need to install several R packages in Google Colab notebook environment. The complete list of packages installed is given in this notebook to ensure reproducibility. First working example of using ggplot2 in R. The first example is to plot 2 variables of mean radius versus worst area in breast cancer dataset as a scatter plot. Here we introduce ggplot2 package that helps us to create the visualization. First, we read the breast cancer dataset by using read CSV function. Then we remove spaces in the column's name to avoid error by using str replace all function. Finally, ggplot and geonPoint functions help us to visualize the scatter plot. So you can see all the syntax here. And final scatter plots look like this. So that's the first working example of scatter plot visualization in our programming language. Changing size, color, and transparency of points. The geonPoint function has attributes color that change the color of points, alpha that makes points transparent. And finally, size, that changes the size of the points. So we color the points, change the color of the scatter plot, something like this, and we make them transparent in the 30% transparent. Add regression line and color the points with different attributes. Based on the above plot, we see that the region where mean radius is less than 15, the relation between mean radius and worst area is almost linear. As a result, first we filter the data to limit ourselves into the region where mean radius is smaller than 15. So we make sure that we filter all the data where the mean radius is smaller than 15. You see the syntax here is shown here. Then we are able to use geomsmooth function with LM option to fit a linear equation into our data. Finally, we need to color the point based on their different class where they belong to benign or malignant cases. So you see all the syntax here. And the visualization, final visualization, which shows different classes when mean radius versus worst area is plotted, as well as showing the linear fitted lines for each class separately. It's really interesting to know that, for example, for this visualization, the malignant class has a better linear relationship in comparison to the benign one. So that's a really takeaway message from this visualization that we created here. Bar chart shows number of cases of COVID-19 in South Carolina. The next dataset that is used in this section for visualization of bar chart is the number of cases of COVID-19 in South Carolina state at the county level. So we just read the dataset similar to what we did for the breast cancer dataset. Furthermore, we limit ourselves to the counties that are filtered as Greenville, Pickens, Lexington, and Aiken and Oconee. We calculate the percentage of cases in each filtered county as just is shown here. Finally, we put the percentage at top of the bar chart and also sort the counties in a descending order based on their number of cases. So the final visualization looks like this. Pie chart shows number of cases of COVID-19 in South Carolina. The above bar chart could be converted to a pie chart by calculating the angular portion of each bar. So we just convert the above bar chart into a pie chart to show the percentage. So the final pie chart looks like this, which is really good for seeing the portion of the COVID-19 cases across different counties in South Carolina. Tropless mass of COVID-19 cases across the US and South Carolina. The dataset of number of cases of COVID-19 across the US at the county level is located in US COVID-19.csv file. So we read that file again with the read CSV function from our library, read our library. A state choropleth function from choropleths R package needs to have two columns in a different in a data frame with region that represent the states and value that represent the number of COVID-19 cases in our example. Furthermore, we aggregate data in each state by summing up all the values within a state or on over all the counties in that state. So we just summarize that. Finally, the map is plotted by using this command. So the final choropleth visualization is shown here. Now we want to import the shape of and position of South Carolina counties. Then we just do that with this syntax. Finally, the data across the US is filtered to contain only the counties in South Carolina. Now we plot the number of cases of COVID-19 across different counties of South Carolina as which is shown here, the syntax. The final visualization looks like this. Line plot for time-dependent data. Line plots are suitable for visualization of time-dependent data sets. One particular example used in this study is the personal savings rate versus time in the US from 1967 to 2015. In this example, we use geom line function to plot the line So just use that syntax and the final visualization looks like this. Statistical models, correlation plot, linear, and logistic regressions. Correlation plot shows the correlation between various variables. For breast cancer dataset, the correlation is calculated as. Note that the correlation matrix is a symmetric matrix. As a result, the only lower triangular portion of this correlation matrix is visualized as by using the ggcorplot library, which is shown here. The next example applies linear regression on breast cancer dataset to find the relation between texture error versus mean radius, mean texture, worst area, worst perimeter, mean perimeter, concavity error, and worst radius. Finally, it's possible to find the best fitted line to show the relation between texture error and, for example, mean radius that tells us that texture error is decreasing by increasing the mean radius when all other parameters are kept constant. We'll find out that how to create a line plot. Finally, it's possible to find the best fitted line to show the relation between texture error and, for example, mean radius that tells us that texture error is decreasing by increasing the mean radius when all the other parameters are kept constant. Logistic regression is suitable for classification of binary variables based on other continuous parameters. In breast cancer dataset, the class of cells which represent benign or malignant classes is a binary variable that is converted to 0 and 1. Finally, the logistic regression is done by using this command. Finally, the probability of class versus mean radius is plotted while all other parameters are kept constant. So it shows that when the mean radius increases, we have a higher chance of getting the other class here. The receiving operating curve that shows the accuracy of logistic regression model is plotted here by using the ggplot and data frame that we had. 3D scatterplot. 3D scatterplots are useful for showing more than 2 dimensions. An example of 3D scatterplot to show mean radius, mean area, and worst radius versus each other colored by class parameters is shown here. Here you can see the final visualization. Scatterplot matrix. A scatterplot matrix is useful for showing several variables versus each other in a single visualization. Here we choose mean radius, mean perimeter, worst area, and worst perimeter for a breast cancer dataset. Now the scatterplot matrix as well as their linear regression and correlation matrix are shown in a single visualization. You can see the visualization here. The final notebook to reproduce this visualization is provided and shared here. You can just click on this link and reproduce all this visualization all together. The last section of this workshop is about saving graphs and plots. Saving graphs and plots in R. ggsave function helps to save plots into files. You can just save whatever you created into a file, for example, mygraph.png. The final notebook to reproduce this visualization is provided here. So that's the end of the visualization class for the R that we had. If you have any question, please shoot me an email, and if you have interest in our other workshops, please go to the sites.google.com, g.clemson.edu, VizLab home, and you find all the information about all the data visualization workshop that we provide. Thank you so much.